All right, to find the relative extrema, we need to take the first and second derivatives. So I'm going to do that first. And so here we go. So for the first derivative, so I'm going to take the exponent, 3, and multiply it by the coefficient. So negative 4/3 times 3 is negative 4x. And then I'm going to reduce this exponent by 1. So I'm going to get squared. And then same idea here. Multiply by the exponent. So negative 21 over 2 times 2 is negative 21. And then x, and I'm going to reduce this exponent by 1, which is just going to be 1, which I do not need to write. And then I'm going to then take the derivative of negative 5x. So negative 5 times 1 is negative 5. And then the exponent of 1 gets to reduce to 0, so I don't need to write it. And then the derivative of a constant is 0. I'm going to do the second derivative at the same time. Okay, so same process. Multiply by the exponent. Negative 4 times 2 is negative 8. Reduce the exponent by 1, so I'm going to get x to the 1. And then here, negative 21 times 1 is negative 21. And then reduce the exponent by 1. There's going to be 0 x's left over. And then the derivative of our constant is just 0. Okay, so the critical points occur when the first derivative is equal to 0 or does not exist. And then we can figure out if it's a maximum or a minimum, relative maximum or minimum, by what the second derivative is at those points. So we need to figure out when our first derivative is equal to 0. So when negative 4x squared minus 21x minus 5 is equal to 0. So one of the ways that we can do this is by factoring. And so I'm going to go ahead and do factoring using the box method. So these terms right here would go here, negative 4x squared and negative 5 would go here. And there's a quick way that you could figure out what the numbers would go here. So if you multiply the first term times the last term, so negative 4 times negative 5, we're going to look for numbers that multiply to equal positive 20, and then add to equal negative 21. So the numbers that multiply to equal 20 but add to equal negative 21, it's going to be negative 20 and negative 1, because negative 20 times negative 1 is positive 20, and negative 20 plus negative 1 is equal to negative 21. So I'm going to put those other new numbers that I found here. Okay, so now to factor, you're going to just pull out a common factor, and then you can use that first common factor to fill in the rest. So if I look going on this side over this way, I see that I could pull out a common factor of negative 4 and x. So negative 4x would go here. Then I can see, okay, this is going to be 1x, so that it would make this little box true. And then negative 4x times positive 5 is equal to negative 20x right here. And then to make this part here, I would need to have negative 1. And negative 1 times 1 is negative 1x. And then negative 1 times 5 is negative 5. So the way that this is going to factor, we're going to get 1x plus 5 times negative 4x minus 1 equals 0. So to figure out when this is equal to 0, you can use the zero product rule. So that means that one of these, either this part needs to be equal to 0 or this part needs to be equal to 0. So I'm going to say and try to solve for when 1x plus 5 equals 0, and also when negative 4x minus 1 equals 0. Okay, here if I subtract 5 from both sides, I'd get 1x is equal to negative 5. So that gives me x is negative 5. Here, if I add 1 to both sides, I would get negative 4x equals 1. And then if I divide by negative 4, I would get x is equal to negative 1/4. So we're going to have either some type of critical point, maybe a maximum or a minimum at these values. So now I can use the second derivative test to figure out if these points are actually maximums or minimums. So here's what I would do. So I'm going to plug in each of these values into this second derivative here. And for time, I'm going to just pull over what the calculator said. So I'm going to get, when I plug in negative 1/4 into this function, I'm going to get negative 19. And when I plug in negative 5 into the second derivative, I'm going to get positive 19. So this number here is a negative, so it's going to be a relative maximum, okay, because the second derivative is less than 0. When I plug in this one right here, I get positive 19, which means the shape is going to look like that. So this is going to be a relative minimum. Okay, now to figure out what the actual values are in the function, I'm going to plug them back into my original function. So I'm going to plug them back into this original function, and I'm going to put what that gives us over here. And for time, I'm going to just drag my calculator screen over. Okay, so everywhere that I see x, I'm going to plug in negative 1/4, and then I'm going to also plug in negative 5. So we're going to have here that our points, so we're going to have this one was negative 1/4, and our output was 827 over 96, which is a terrible number. And that one we saw is a maximum, a relative max. And then this other one, we plugged in negative 5, and we get out another horrible number, negative 377 over 6. And that one had a positive second derivative, so that is a relative minimum.